Brad Williams, Frugal Finance. Let's continue with more on options. How about interest rate options, the option adjusted spread, or the OAS? We turn to analytic techniques for valuing options. The first of these is the option adjusted spread. The option adjusted spread, OAS, is the yield differential between corporate bonds or mortgage instruments with an embedded option and a Treasury bond. The Treasury bond is chosen so that the two instruments will have essentially similar maturities and coupon characteristics. Defined, the yield spread provides a measure of the option's value and the default risk differential between the Treasury and the bond or mortgage instrument. Sometimes the OAS is defined between two securities of the same basic default risk, coupon and maturity. In this case, the OAS would embrace only the yield differential due to the option feature inherent in one of the two securities. Because it is difficult to find comparable bond or mortgage instruments, it is more common to compute the OAS relative to a Treasury instrument. The OAS is often applied to corporate bonds with call provisions and to home mortgages with the option for the homeowner to prepay the mortgage. In each case, the spread is typically calculated as a spread between the yield on the instrument with the embedded option and a Treasury instrument with similar cash flows. The OAS is a number of basis points that must be added to that yield on the Treasury instrument so that the spread adjusted Treasury and the corporate bond or mortgage will have the same price. As an example, consider a 20-year corporate semi-annual coupon bond with a coupon rate of 10%. The bond is callable in 5 years and is currently priced at 97.25% of par. The corresponding yield to maturity for the bond is 10.3278%. The call feature embedded in this bond obviously has a value to the issuer, but the value of that option is unclear. Under the OAS technology, a spread to Treasury is computed to provide a metric of that value. Consider also a T-bond with 10% coupon and a 20-year remaining maturity. The T-bond is priced at 108.53 of par and yields 90681. So we have the following. We have the instrument, we have a price, and we have a yield to maturity. Callable corporate bond price 97.25. Yield to maturity 10.3278%. Treasury bond 108.53, 909.681, and then yield to maturity difference 1.2597%. One could say, is that the embedded option value? The two promised cash flows on the two instruments are the same. The difference is the yield to maturity stems from two sources, the difference in default risk and the presence of that call feature on the corporate bond. Table 19.5 shows detailed information on these two bonds. The first column of the table lists the 40 periods of the life of each bond, while the second column sets out the semi-annual cash flows. All right, right here, notice there's some hidden rows. Just go with this then. Second column sets out the semi-annual cash flows that are common to each bond. The third column shows the zero coupon annual rate appropriate to each period, which reflects a term structure assumed for this example. The short-term rate is 8%, rising to a rate of 10.7% over 20 years of remaining maturity on the bonds. Column 4 shows the zero coupon factor for each semi-annual period, while column 5 presents the zero coupon factor appropriate to the cash flows for each period's cash flow. The zero coupon rate in column 3 gives a unique discounting rate for each period's cash flow. This reflects the shape of the yield curve instead of discounting flows from various times at a single yield to maturity. The zero coupon factors of column 5 are the ZOT term for this particular term structure environment that we reviewed earlier. Go back to continuous compounding in those 4 sections, or look at section 3 in futures, forwards, and zeros. And there's a comprehensive understanding of exactly what I just mentioned. Column 6 shows the present value of each of the cash flows from the T-bond, which total 108.53. Each element in column 6 is just the corresponding cash flows from column 2 divided by the appropriate factor from column 5. Given the first 6 columns of information in table 19, we are now prepared to find the OAS. Specifically, we need to find the number of basis points to add to each zero coupon semi-annual factor in column 4 that will equate the price of the T-bond and the price of the corporate bond. Essentially, it's a trial and error approach. For example, 0.007447 generates a cash flow of 9567. 005447 generates a cash flow of 9887. This is found by an interactive search. When 64.46 basis points are added to the zero coupon semi-annual discount rate for each period, the present value of the Treasury cash flow will be 97.25, which is the same price as the corporate bond. Column 7 of table 19.5 shows the zero coupon factor that results from adding the 64.46 basis points to each semi-annual discount rate, while column 8 shows the resulting present value of each cash flow, with 64.46 basis points being the semi-annual OAS. The annualized OAS is just twice that, or 128.02 basis points. Figure 19.4's graph, not shown, shows the yield curves for the Treasury and the callable corporate bonds. They have the same shape with the callable bond curve. It lies 128.9 basis points above the T-bond curve. The basic procedure for finding the OAS can be elaborated more fully. For example, one might consider the effect of varying interest rate environments on the instruments, such as a steepening yield curve or downward sloping yield curve. Also, the potential exercise of the embedded option under different interest rate scenarios can affect the relative spread of the instrument with the embedded option versus treasuries. For home mortgages, prepayment can occur at any time, so the incentive to prepay under the different interest rate regimes can be analyzed. These problems are often tackled using various kinds of simulation analysis. For example, one might specify a probability distribution for possible changes in short-term interest rates, and then conduct a Monte Carlo analysis to generate numerous interest rate paths and the corresponding price paths for the bonds. In fact, there's quite an active industry in analyzing instruments with embedded options, particularly in the mortgage arena. Here we have our periods 1 through 40. Cash flow, $5 every 6 months. Remember, it's a 20-year deal. Zero coupon rate, 0.8. I don't know if I did the math here. Nope, I did not. I should have. Control 2. Cash flows, periods, cash flows, and 0 are given. 0 semi-annual Treasury discounts. We're just taking this and divided by 2. 0 annual Treasury discount rates. We go F72 times F73. All we're doing is, remember, move back, move forward, move back, move forward. F72. So then here we go, F73 times E74. We're going here times this. Then we're finding the present value of T-bond cash flows. So we go C71 divided by F71. And that'll give us the present value of our cash flows. And then we take the OAS adjusted discount factor, which is E71, 1.04, plus H68, 00646. And that must be the trial and error. So then what do we do here? We have 128.29. OAS C71, $5 divided by H71. And so we get 107.86. Brad Williams, Frugal Finance. See you soon.